Welcome to Copilot Podcasts. Your Gmail has been quietly making decisions about your inbox, learning what's spam, what's important, what you actually care about, and it figured all of that out entirely on its own without a single human writing a rule for every scenario. That's machine learning, and it's already running in the background of your life whether you realize it or not. Today, we're breaking it all down, what machine learning actually is, the 3 core types you need to know, and how it powers the apps and tools you use every single day. By the end of this episode, you'll be able to explain machine learning to a friend without sounding like a textbook. And to help us get there, I've got someone who lives and breathes this stuff. So, let's just start at the very beginning. What even is machine learning?
So the cleanest definition I've come across, and this is straight from Geeks for Geeks, is that machine learning is a branch of artificial intelligence that focuses on developing models and algorithms that let computers learn from data without being explicitly programmed for every task. In simple words, it teaches systems to think and understand like humans by learning from the data.
Okay, but learning from data, what does that actually mean? Like, what's happening under the hood?
Right, so the best way I've seen it put, and this comes from a Python guides tutorial, is that in traditional programming, you write explicit rules. Like, if the price is over 500 and the rating is above 4, recommend the product. You're the one writing the logic.
Okay, that makes sense. You're basically writing a rule book.
Exactly. But in machine learning, you flip that. You show the program 100,000 examples, here are products, here's where the customers bought them, and the system figures out the pattern itself. The magic, as that same source puts it, isn't the math. It's the idea that the computer figures out the logic, not you.
Wait, so you're essentially outsourcing the rule writing to the data itself?
That's exactly it. And a really concrete example of this, one that comes up a lot, is email spam filters. According to TechLad's guide for non-technical people, rather than setting strict criteria for identifying spam, the algorithm learns to differentiate between millions of spam and non-spam emails over time. Gradually, it develops the ability to filter out spam with minimal human intervention.
So your Gmail isn't following a list of spam rules someone typed out. It's actually learned what spam looks like from experience.
Precisely. And that's what makes it so powerful and, honestly, a little wild when you think about it. The system gets better the more data it sees. More examples, better predictions.
Okay, so now I'm curious. Is all machine learning the same, or are there different flavors of it?
Great question. So according to Geeks for Geeks, machine learning is mainly divided into 3 core types. The first is supervised learning, the second is unsupervised learning, and the third is reinforcement learning. And they're pretty different from each other.
All right, break those down for me.
So supervised learning, this is the most common one, and honestly the best place to start if you're new. You give the model labeled examples, meaning input plus the correct answer, and it learns to predict answers for new inputs. Think predicting house prices from size and location, or classifying emails as spam or not spam. That's supervised learning.
So it's like a student learning with an answer key.
That's a really good way to put it. Now, unsupervised learning is different. You give the model data with no labels at all, and it finds hidden patterns or groups on its own. According to Geeks for Geeks, examples include grouping customers by purchasing behavior or detecting anomalies in network traffic. There's no answer key. The model just explores.
Interesting. And reinforcement learning?
Reinforcement learning is the most intuitive one, honestly. The model learns through trial and error, it takes actions, receives rewards or penalties, and gets better over time. The Python guide's tutorial describes it as training a game-playing AI or teaching a robot to walk. It's basically how you'd train a dog, but for software.
Okay, I love that. Rewards and penalties. Very dog training energy.
Ha, yeah, it really is. And here's something that puts all of this in perspective. The history of machine learning actually goes back to the 1950s. According to Geeks for Geeks, the first scientific paper on the mathematical model of neural networks was presented back then. So this isn't some brand new idea. It just needed decades of more data and computing power to really take off.
Wait, the 1950s? So this has been cooking for like 70 years?
70 plus years. And it became popular in the 20th and 21st centuries, specifically because of the availability of more complex and large datasets, and advances in natural language processing, computer vision, and reinforcement learning. The ingredients were always there, we just needed enough data to make it work.
That's kind of a wild reframe. It's not that the idea was new, it's that the world finally caught up to it.
Exactly. And now it's everywhere. According to Analytics Insight, machine learning is already embedded in the tools most people use every day. Spam filters, shopping recommendations, bank fraud alerts, AI chatbots, all running on it, quietly making decisions in the background.
So let's actually dig into how it works step by step. Like if someone were building a machine learning system from scratch, what does that process look like?
So the process is actually pretty consistent across every ML project, whether it's a simple model or a massive neural network. According to Analytics Insight, step one is always defining the problem. What are you trying to predict? What does success look like? That question is more important than most tutorials admit.
So you can't just throw data at a computer and hope for the best.
Definitely not. And step two is collecting data, and this is huge. Analytics Insight describes data as the fuel of machine learning. The system learns from examples, so the volume and quality of data directly determines how good the model can get. There's a phrase that gets used a lot in this space: garbage in, garbage out.
Garbage in, garbage out. So if your data is bad, your model is bad.
Exactly. And then you train the model, you feed it the data, it finds patterns, it adjusts. Then you test and validate it with new data to make sure it actually works in the real world. And finally, you deploy it. According to TechGlad, once validated, the model is deployed to automate tasks or provide predictions, like a movie recommendation on a streaming site based on your viewing history.
So Netflix recommending your next binge, that's a deployed machine learning model.
That's exactly what it is. And it's not just Netflix. According to Geeks for Geeks, machine learning is used in healthcare to diagnose disease based on past patient data. It's used in finance to minimize fraud and assess risk. It's used in retail to avoid overstocking by understanding past sales data. It's used in targeted advertising. The list goes on.
Okay, so it's not just a tech company thing, it's touching basically every industry.
Right. And some of the examples are really striking. According to Geeks for Geeks, voice assistants like Siri and Alexa are literally learning your preferences and accents over time. Self-driving cars are improving their decisions using millions of miles of driving data. Search engines are refining results based on how users interact with them.
So every time you click a search result, you're kind of training the algorithm.
In a sense, yes, your behavior becomes data, and that data feeds back into the model. It's this continuous loop of improvement.
That's a little mind-bending. Okay, I want to bring up something from a Medium piece by Indalani Simbaine because I think it reframes ML in a really useful way for people who aren't technical. The piece talks about how ML isn't magic, it's a tool for making faster, data-driven decisions. And it uses this analogy of a bartender who remembers your favorite drink and suggests a new one. That's a prediction model.
I love that analogy. And the same piece talks about classification models being like a librarian sorting books into categories, that's your spam filter, and optimization models being like Waze constantly rerouting based on traffic, that's Uber optimizing driver routes in real time. These are all machine learning, just described in human terms.
And that's kind of the whole point, right? Once you have the right mental model for it, it stops being intimidating.
Totally. And there's actually a really interesting analogy from CTO Sync. They describe machine learning as an apprentice chef who improves with more practice and better ingredients. The more you feed it, the better it gets. That shift in language, as they put it, helps people view ML as practical and supportive rather than abstract or intimidating.
Okay, but here's where I want to push back a little because I think a lot of people hear all this and think, cool, but that's for engineers. Is machine learning actually something a regular person with no coding background can get into?
That's a fair challenge. And the honest answer is it depends on what you want to do with it. If you want to understand it conceptually, absolutely no coding required. But if you want to build models, you do need to learn some tools. And the good news is there are really structured paths for that.
Like what?
So Machine Learning Mastery lays out a 5-step process for beginners. Step 1, adjust your mindset. Believe you can actually do this. Step 2, pick a process, a systematic way to work through problems. Step 3, pick a tool. For beginners, they recommend Weaker Workbench, which requires no coding. For intermediate learners, the Python ecosystem. Step 4, practice on datasets. Step 5, build a portfolio.
So there's literally a no-code entry point.
There is. And Machine Learning Mastery makes a really important point. The best way to learn is by completing small projects, not by reading theory endlessly. Books and courses give you recipes and snippets, but you never see how they all fit together until you actually work on a real problem.
That's actually really good advice for learning anything, not just ML.
Completely. And here's something that really signals how much demand there is for accessible ML education. Microsoft has a free open source curriculum on GitHub called ML for Beginners. It's 12 weeks, 26 lessons, 52 quizzes, and it has nearly 88,000 stars on GitHub. That's a massive number. It tells you how many people are actively looking for a way in.
88,000 stars. That's not a niche interest. That's a movement.
And Microsoft's own learning platform, Microsoft Learn, frames it this way. Machine learning is the basis for most modern artificial intelligence solutions. So understanding it isn't just a nice to have, it's foundational to understanding where technology is going.
Okay, I want to make sure we're being balanced here, though, because ML gets a lot of hype. Are there limits to it? Places where it falls short?
Absolutely, and this is important. The Medium piece by Indilani Simbine is pretty direct about this. ML is not perfect, and humans are still needed. The model doesn't actually understand what it's doing. It detects correlations and makes predictions based on past patterns. It doesn't understand coffee sales, to use their example. It just finds patterns in the data.
So it's pattern matching, not actual understanding.
Right. And that distinction matters a lot. If the data has biases, the model will reflect those biases. If the data is incomplete, the model's predictions will be limited. That's why the garbage in, garbage out principle is so central. The quality of your data is the ceiling of your model.
So it's a powerful tool, but it's only as good as what you feed it.
Exactly. And that's actually a really healthy way to think about it. Not as magic, not as something to fear, but as a very sophisticated pattern recognition tool that needs good data, a clear problem definition, and human oversight to work well.
I think that framing is so useful. It demystifies it without underselling it.
And it also makes it less intimidating to get started. Because once you understand that ML is fundamentally about showing a system examples and letting it find patterns, that's a concept anyone can grasp. The math gets complex, sure, but the core idea is surprisingly human.
Yeah, and I think that's the thing that gets lost in a lot of the coverage around AI and ML. It gets framed as this alien, unknowable thing, but it's really just a very fast, very data-hungry version of how we learn, too.
That's a great way to put it. We learn from experience, ML learns from data. The mechanism is different, but the principle is surprisingly similar.
Okay, so let's also talk about the types of problems ML is actually good at solving, because I think that helps people figure out where it's relevant to their own lives or work.
Sure. So according to Geeks for Geeks, ML is particularly strong at solving complex business problems that traditional programming can't handle, things like language understanding and medical diagnosis. It's also great at handling large volumes of data quickly, automating repetitive tasks with high accuracy, and personalizing user experiences.
And the personalization piece is huge, right? Like, that's what makes Netflix feel like it knows you.
Exactly. Geeks for Geeks describes it as ML analyzing user behavior to deliver highly relevant content. Netflix suggests movies and shows based on your viewing history. E-commerce sites recommend products you're likely to buy. It's all the same underlying mechanism. The model has learned your patterns.
And it keeps getting better the more you use it.
That's the self-improvement piece. According to Geeks for Geeks, ML models evolve and improve with more data, making them smarter over time. They adapt to user behavior and increase their performance. So the system you're using today is more capable than the one you used 6 months ago, even if you didn't notice.
That's kind of a wild thing to sit with. These systems are quietly getting better in the background.
And that's also why understanding the basics matters, not just for people who want to build ML systems, but for anyone who interacts with technology, which is basically everyone.
All right, so here's what I want to make sure we land on before we wrap up. If someone is listening to this and they want to actually start learning machine learning, what's the most actionable first step?
The most actionable first step, according to Machine Learning Mastery, is to adjust your mindset first. Believe that you can actually do this, because the biggest barrier for most people isn't the math or the code, it's the assumption that it's not for them. Then pick a structured process, pick a beginner-friendly tool like Weaker if you're not ready to code, and start with a small, real dataset.
And Microsoft's free GitHub curriculum is right there if you want something structured.
12 weeks, 26 lessons, 52 quizzes, all free, all open source. That's a pretty low barrier to entry for something that's becoming foundational to how the world works.
So when you step back from everything we've covered today, here's what this really comes down to. Machine learning isn't some distant, futuristic concept. It's a branch of AI that's been in development since the 1950s. It runs on data, it comes in 3 core types, and it's already woven into the fabric of your daily life. from your inbox to your streaming queue to your bank's fraud detection.
And the core idea is genuinely simple. Instead of writing rules, you show the system examples and let it figure out the patterns. The complexity lives in the implementation, but the concept is something anyone can grasp. And once you have that mental model, the whole landscape of AI starts to make a lot more sense.
Yeah, and I think the takeaway for anyone listening is this. You don't have to become a machine learning engineer to benefit from understanding it. But knowing what it is, how it works, and where it shows up gives you a real edge in how you think about technology, your career, and the tools you use every day.
Exactly. And the resources are genuinely there. Free curricula, beginner-friendly tools, structured learning paths. The question isn't whether you can learn this, it's whether you're going to start.
So here's where we land. Your Gmail has been doing machine learning this whole time, learning your habits, filtering your noise, quietly getting smarter every single day. Maybe it's time you learned what it actually knows and how. Thanks for listening to Copilot Podcasts, and the next time an app seems to read your mind, you'll know exactly what's going on.